Hey guys, welcome to this video. I hope you checked out my spiral example that I've done last week. It's a example that you see here on the screen, and today my idea was to do a code review for this script and explain a bit the code behind and how it all works. I think code reviews in general are a great way to transfer the knowledge to other developers, but also to sort of check with yourself if you did okay or not. I hope I did. You can definitely comment on the code, give suggestions if you see some things that can be optimized. So far, I think it does quite okay for its purpose, but let's dig in and let's see where we end up with this code review. It's the first one on BitByBit, so I hope you enjoy it. I hope it explains to you a bit more what the code does. So just to briefly introduce you to this example, you see here the code that is written. That's the code you need to produce this shape that you see in the background. When you click this web canvas button, you will open the 3D environment, and then you can inspect and rotate the model. That's what it is. It's a spiral. It's parametric spiral. I can adapt certain parameters on it to change its appearance. We can do that. We can just try a bit to play, like we can put it on 606, for example, the number of rays, and see what happens. So it should be, of course, producing more surfaces, more subdivisions. So probably it will also take a bit longer to compute. But when it's done, you see that the result is still nice. It's more intense, has more subdivisions. And that's what you would expect from parametric model, is that it's changing its behavior when you adapt the parameters. So there are more things, of course, you could try out. I will put it on a bit lower resolution now with 200 rays. We can change this parameter, for example. This one is nice. It shows you that there are certain tricks done with those spirals that can lead to interesting results. So this is a spiral which doesn't go full way till its partner. It's also an interesting spiral, nothing bad about it. Looks quite okay, also interesting visually. So that's all parametric. That's all being regulated by the script. And also it shows you the power of the model. It's not something that you modeled by hand, and whenever you need to change some small thing, you have to redesign the whole system. You see here that it's more that you code the behavior of the parametric model, and then whenever you need to adapt, you just change those parameters that allows it to adapt. So let's put it back to 0.47. That's the magic number. We'll go deeper in another canvas that I have open to analyze what those parameters do. But you see that everything basically here is for your control. You can change things like colors and parameters and just about anything you want and experiment what the result is. But okay, so today's video's purpose is to just dig into the code, and I prepared a separate canvas to show you how the script is organized and which parts do what. It will not be a very deep code review that will answer all your questions about the NURBS curves and everything, but I'll at least try to build a conceptual understanding for you on where and how do I start when thinking about these problems and scripts. So what you see here is a script that has certain components disabled, and when I will be explaining step by step every part of the code, I will be enabling those components to just show what the part of the code before that component does. In that way, you will understand, okay, what is the thought process behind this spiral and where things start. So what you already see is a spiral that is just made out of points, and that's where actually we start. It's not something very complicated. You don't start making surfaces in the first place. Usually you start with some sort of carcass, a framework, if you will. And these points give me a framework. So that's where I begin my journey into this shape. So we're lucky in the sense that BitByBit already gives us some components to make those spirals. You see that we have here a block that is called spiral with vector, and with that you can regulate all sorts of aspects of the spiral. You can put, for example, the radius for the spiral, and this will just make it smaller twice. So you can play around with those also in the real spiral, I guess. But the most important thing to realize is that we just begin with points. This component produces a points, and we set those points on the variable spiral points. Well, that's it. It's pretty simple. And what I do, to just for clarity's sake, you will not find this part in the real script. So if we look here, you see that the draw part, we don't draw points, we don't need them. Well, here we do draw them just for sanity and clarity sake. And what you see is that there are basically points on the spiral. We asked to create 404 points, and that's what the component does, and we visualize them. Okay, pretty simple, right? So we start with points. They form the basis for our code. And now the next line, so we can now forget those points. I will disable them for a bit. The next part takes those points and it produces the same amount of points as the spiral has, but all on the origin x, y, z being 0. So with that we can form many lines that go to the center, and I will just visualize them now for you. I hope you will see where I'm going with this. So now you see the rays going from those points. Let's also visualize the points. It's gonna help us to understand what is happening. Okay, so you see that in this 3D view, we have now produced, for every outer point of the spiral, we produced a line that goes towards the center. And that means that we now have another part of the frame, which is just lines in general. These are not yet very useful because they all go towards the center, and you see that each line that starts from the top, it sort of goes also in the space of other lines, and we don't want that. We would only like to, the idea is that we would like to just sort of cut this line on this perimeter. So the outer line should just go like this and end here, and the same could be said for these lines. They should sort of be cut here. So how do we solve that problem? Well, there are many ways. Of course, you could sort of compute the intersection. You could, but that's quite expensive. What I did, I just found out that there's well, magic percentage basically for this spiral. That if I put the point on 0.47 length of the line, that it will end here. And I will just show you this code to make it a bit more clear what I mean. So let's disable this for a while. It's not really useful because it's just an in-between step. Again, so those in-between steps you will not find in the real code, but you will find this part and not the draw part. So let's disable that. Now we can look into this magical part that I've just mentioned, you see that on the line I can find a point at parameter, and this is considering like from 0 to 1. So if you put parameter on 0.47, it will find a point that is close to 50% of the length of the line, and it will be around in the middle, and that's where our spiral ends. So we can now enable this part, and you will see what I achieved with that. So yeah, it's pretty clear, right? We sort of ended up with lines that are cut exactly on the spiral's edge, and that's what we wanted from the very beginning. Now we have a nicely ordered lines, and this is already going to the right direction to building us the even the better framework. Okay, so next thing that we do, and this part I changed just a little bit to be able to visualize it. Let's disable this block now. Let's leave it enabled. It's quite okay. It's quite okay to have that. It's good to have it. So another part which is a bit more complex is that we have 4 loops. So we do a few things here. We first try to group those lines into the groups of 3. And this is the component that does that. We do that because we cannot create the surface just by having one curve. Usually surfaces are created by having multiple curves involved, and that's what this code does. It sort of orders our framework into the right, into the better shape. And what we do is that when we create those groups of 3, so we group those 3 lines together, then the next 3 lines together, that's when we iterate through those groups. And that's what this for loop does. It iterates through all the arrays in groups of 3. This part may be tricky to understand if you're a beginner, but eventually you will understand. I think it's not rocket science, definitely. So when we do that, we end up with segmented line curves, which contain 3 items, and this for loop iterates through those 3 items. We could be grouping them to bigger amounts, but that doesn't change much. Parents will change, of course, because you will end up with bigger surfaces. But yeah, it's mainly just groups of 3 that produces a nice rounded surface. Okay, so let's get back to this loop that iterates through through all the segment curves, and we get access in this loop to every line curve. And what we do is we need to create more 3-dimensional curve than the line. You see that this model so far is very flat, while this model here, well, it has thickness to it. It's still, of course, from flat surfaces, but it's 3-dimensional. You see that. So what this part of code does is it goes through the line. It finds points on it, on parameters that are indicated here, and it moves them away from the line by direction Z. That's what you see here. There are some magical factors involved here to sort of get you this growth effect that you see here. the curve begins small and then it grows. So those factors are useful for that. But mainly the purpose of this part of code is to create a more three-dimensional curve that could be used to create a surface, so that the surface wouldn't be flat. And I have here the component that shows you how those points look like at the end when I find them. So now you begin seeing something that resembles more the three-dimensionality of the surfaces that you see in the other example. It's not flat anymore. All those points that were produced are based on the lines, of course, and they are just moved away minus or plus direction based on the coordinates of the environment. And what those points give us, they give us a possibility to continue the journey and create the curves through those red points. So we can enable this one, this draw curves component, and let's execute the script again, and let's see what that gives you. So we had all those points in the framework, and now we just said, okay, let's make the curve that goes through those points in groups of 3. So you see that also, if I zoom in, that this curve, and this curve, they go together, and then you have another small curve where the next group begins, and then it grows again. And that's how you get this effect of sort of dragon skin effect of size variation between the curves. So the 3 curves form this surface, and each is a bit smaller than the other. And those magical parameters that you saw here, they just control it. So these ones, the curve scaling factor, you can look into the loop where they are applied and how big are they. These are just values that you can also change and experiment what they do in the real code. But for the review, it doesn't really matter too much. I think it's mostly the purpose here is to just explain you where what the code does and how this how we go through various steps in the process, just beginning by points and then going into lines, and from those arriving in 3-dimensional curves. And from those 3-dimensional curves, of course, the last step is just to loft them by using this block of code here. And when we loft them, we add them to collection. When we have this collection, we just visualize, and that's the last step of the puzzle. And we can enable this block of code. Let's put the opacity to something really small. I don't know what the effect will be of showing those surfaces, but let's wait and see. Okay, so maybe it's not very clear. Okay, I put the opacity to a bit to a small value. Let's put this to something like 0.4. So we would see the surfaces and the curves and points all in one model. So here it is. That's how your geometry looks like. You know, we began with just a bunch of points. We created curves, and from those curves we could then arrive at the surfaces. And even with this with this opaque example, I think it looks quite gorgeous, this spiral. I hope you've learned something from this video. I'm not sure we went through exact intricacies of the code itself, but this is more a conceptual review. I hope it answered some of your questions on how things should be assembled together in BitByBit. So that's it. I hope you guys subscribe on YouTube. If you have questions, just throw them into comments and I will try to answer for you. See you later. Bye.